Welcome back to my garage. I'm starting this video here because it just fits so well with what you'll see I'll be doing in this video, and also with just how how I work with things. So this video is sponsored by Brilliant, and I've been using Brilliant for I think 2 years now, mostly for fun. But fun for me is learning. So I've been using it for math, for touching up on my math skills and learning new stuff, and just kind of a relaxing activity. Brilliant is where you learn by doing, and I like learning by doing. And they have thousands of interactive lessons in math, data analysis, programming, and AI. It's a uniquely effective learning platform where you build understanding from the ground up. And I really like that approach, like building understanding. That's what everything is about, for me at least. Like get an understanding of things. It's not about memorizing stuff. Actually, I make a point for myself to not try memorizing stuff. If I can't find info about something in like 10 seconds, well, don't memorize it, because there's no point in memorizing. The thing you need to learn is how you need to get the understanding and see connections between stuff. Each lesson is filled with hands-on problem solving that lets you play with concepts, and that's proven to be 6 times more effective than just watching an instructional video. Build critical thinking skills, build problem solving skills, not memorizing skills. That's what really resonates with me. So why this fits so well right now is because Brilliant has lots of lessons on programming, like thinking in code and be a creative coder and stuff like that. And I really need to learn about thinking in code and just programming in general, because I suck at it. My approach is to find some example of something close to what I need, and then try to like reverse engineer that to find out what I have to change about that code to use it for my purpose. But I don't really have a good understanding of coding. That's about to change now, because I need that for this EFI setup I'm working on. So with Brilliant, I can get more familiar with coding languages, learn the essential coding elements, and develop my mind to think more like a programmer. To try everything Brilliant has to offer for free for a full 30 days, head to brilliant.org/twostroke or click the link in the description. You'll also get 20% off an annual premium subscription. Thank you, Brilliant. Welcome back to my garage. Lots of things to talk about since last time, and lots of mess. First, the pulsing flow from that pump. There's been several good suggestions about how to eliminate or at least reduce the pulsing. More volume in the high pressure line. Good suggestion. Accumulator / damper thing. Good suggestion. I think I'm going to try both in combination as a start, just by adding this CO2 tank in line, sitting upright. So there won't be any active like air pressure damping thing in here. Will be extra volume, and hopefully sitting like this, it'll trap some air and kind of self-regulate. So higher pressure, smaller air volume, but higher pressure in here, and it'll do like that. Someone pointed out that this pump looks exactly like the pumps in DAQ 200 DSV, I think, automatic 7-speed automatic gearbox. So a 7-speed automatic gearbox uses these. With that information, I actually found some pictures and also a video showing the insides of this. And it is just a normal 2-spur gear external gear pump. Someone said it might be manufactured badly, so that it's pushing like more volume some places in the rotation versus others. Could be, but it could still be the motor. And people are suggesting a censored motor with pretty much what I was talking about, using an O drive or a VESC sensor, like feedback, just like a servo drive, like CNC servo drive type setup. Might need to run a bypass so that the pump can spin much faster at idle, and then ramp it up towards higher RPM and throttle openings. There's a bypass, like in normal mechanical fuel injection, there's the pump coupled to the engine, so spinning with the engine, usually half speed, like cam driven or belt driven, but half speed. And then there's a bypass valve, and there's also like this extra idle bypass. And then as RPM and throttle opening increases, the drum valve opens up and lets more through to the actual injectors and not through the bypass. There's already an output for a bypass here and an adjustable bypass thing, pressure bypass. Second point, pure nitromethane injection. First of all, I've ordered surface gap plugs. Kept on running after I shut off the ignition the last run in the previous video. And that's auto ignition, and that's like, I'm 100% sure that's the ground strap glowing. What does the plug look like now after our tiny little bit of experimentation? There's no evidence of anything going on. And this was an old plug. It might be the carbon deposit that starts glowing. Fuel is dissolving the lacquer here. I can feel a tight spot here. Could also be seals dissolving. Seals seem... Nope. Those blue seals, they are not happy. And they're... well, I can get new seals. Green ones, fine. Black ones, fine. Blue, not fine at all. So that's our problem, probably. Hopefully I can get this size locally. It's 8 by 16 by 4. That's probably a fairly standard size. I think there's some kind of a paint. This is lacquer. Input side is O-ringed off from the output side, so that seal doesn't have to take any high pressure. To get any further, we will have to pick up a new seal. I'm going to bring this downtown and see if I can get a replacement seal, hopefully locally. And the green stuff seems to do fine. And yeah, the seal was our problem. I could not find a suitable seal locally, but luckily I've got these, which are 8 by 18 by 5 millimeters. There's enough material here to just machine out the pocket to fit these. We're back in business with a 0.9 millimeter nozzle with a 1 bar check valve in it. So let's see if it's less pulsy now. So spinning slowly is a problem. So this is a problem. If we create a controlled leak here and release some pressure, could that help? Let's try this tank in the high pressure line. Here's the pressure release return to tank valve. It's just a conical tip on a spring. If I remove this and then screw this back in and have a short little piece of tubing and connect this to here, that should work as some extra volume. stuff is very much not meant for the high pressure, so let's not push it. Let's see if the pulsing is better. So this is just a test setup. Hopefully there's no leaks here and this doesn't just burst, and hopefully there's less pulsing. Let's see. Yeah. There's still some pulsing going on, but much better. I want to test this. I want to see if I can make the bike idle on this, because I don't need any throttle position sensing or anything for that to happen. I just need to create a little adapter to fit that injector in here. That's all I have time for today, so tomorrow morning happens tomorrow morning. I've decided to hook the TPS up after all now for this test, because then we have some little control over airflow. See if we can get it to somewhat run in some throttle position in some part of the fueling map. Ignitec hooked up to the computer, and I'm going to hook up the TPS sensor and see if it works. So I'm seeing full throttle now, and I'm seeing zero throttle there. I gotta switch over the plus and minus. 0%, maximum full. So now we gotta create a starting map. We gotta get this to communicate with the Arduino. So I wonder what kind of a PWM signal we're seeing out of this. And I'm seeing nothing at all. There's a cheap, more refined version of this at a local shop. I think I want to go and get one of those. It can measure duty cycle, PWM, like it's an automotive. I need something to be able to properly read PWM, and I haven't got that. So I think that's what I'm going to do now, and I'll be back. More advanced multimeter acquired. Set to read duty cycle, and currently we're sitting at 0% duty cycle, because the engine is not running. Now I'm going to spin it up with the starter to about 3000 RPM. Set to send 50% duty cycle out of the Ignitec. Let's see what that corresponds to here. It's reading 53 or so duty cycle. And now let's close the throttle, which means we should see just 2% duty cycle. Looks to be working. So now everything is reading 100%, which means it should read 100% now, regardless of RPM or throttle position. I'm not sure if it's I think the meter is slow. Now it's 0% throttle opening, we should see 0% duty cycle. It's a little bit jumpy. Now let's see if it reads between 33 and 67 duty cycle, which is what I've set it to. Now we should see 17% duty cycle, as duty cycle and throttle opening percentages are the same now. Good stuff. I think we're dialed. Seems to be working. It seems to become a little bit erratic at wide open fuel duty cycle. Use this signal and make the Arduino interpret this to the servo pulse width modulation signal type into our injection setup. Last time you saw me was Friday, this is Monday, and I can't really remember where I left off. But I've created a sketch now that should work with like translating what this puts out to what the ESC for the electric motor wants. And now I'm gonna map it. Check the lowest throttle position setting and the highest, and then map those values so that we can so we have a range to work with, or this knows what range it has to work with. Set the map for the Ignitec to put out 1%. I don't want to go 0% duty cycle because that'll be a 0 and won't work with how I've got things set up here. But I'll set it to 1%. That'll be our lowest output from this. And I'm going to check what that equates to here. It says 8 and minus 20. 8 and minus 20, that's weird. Weird numbers. I'm serial printing two values here. I'm going to serial print the value coming from here. Start with that. I just got a bunch of rubbish numbers. Okay, let me troubleshoot a little bit. So it doesn't seem to come from this. So that's giving us an 84. I think 1% was just too low of a value. Okay, at idle. There's probably some fuel in there now, so let's see if it fires without me adding any fuel at all. So no. Let's add a little bit of fuel. Oh, unscrew the nut. Oh! Good thing I have glasses on. We blew the... Oh, fuck. Ugh. Oh! I got a little peppermint schnapps there. We'll have to replace the nylon tubing there because it'll burst with higher pressure, as you saw. Gotta remember to turn the pot the right way around. Maybe add a kill switch, actually. It does want to run, so it's just a matter of fuel mapping now. I gotta figure out a way to make this, make it work, find out what's wrong, where I went wrong. But this is all the time I have now because I gotta edit, and I have planned for another video I need to get started on. See you next time.